So let's look at question number 6 now. Describe the locus of points inside the given circle, which are equidistant from two fixed points lying on the circumference of the circle. So this is an interesting problem. And see, one thing that we need to understand is that we are finding the locus of points which are inside the circle. That is the first information that we need to digest. So we are finding the locus of points which are inside the circle. And then what is the condition? The condition is that these points, the locus of the points that we need to find. What is the condition on these points? Are equidistant from two fixed points lying on the circumference of the circle. So, for example, if this is a circle and two fixed points lying on the circumference of the circle, so there will be these 2 points. Now we have to find the locus of the points which would be equidistant from these 2 points. Let me call these 2 points P and Q, and let our let our point be O. So this point O would be inside the circle, and it will be equidistant from these 2 points P and Q. So let's try to look at this question. Pretty interesting question. So these are our points P and Q. They can be any point. You can take it here also. So P and Q. Now this is the point that I am looking for. This point is equidistant from P also and from Q also. Yeah. So let us say this is the first point that we have got. There can be another point. Again, this point is equidistant from P and Q. This is another location where the condition will be satisfied. Let me call this O dash. There'll be another point also. So all these points are possible, and all these points, they satisfy the condition that they are equidistant from point P and Q. And see, remember that the first line said that all these points would be inside the circle. Now, if we join a line, so this would be a line. And just let me use a separate color. Okay. So if I draw a line from all such points, there's an interesting thing that will happen. There'll be a certain point on this locus that I have found. Let me call this AB. There will be an interesting property. There will be a point on this line. There will be a particular point. Let me call that Z, which will actually be the radius. So this distance and this distance would be the same. These two distances would be the same and would be equal to the radius of this circle. Now, if you try to think, this line passes through the center of the circle, because we have found this Z to be the center of the circle. So actually, I think you would have now understood that this AB is actually the diameter of the circle. So the locus is actually the diameter of the circle. So when they are asking us describe the locus of points inside a given circle, locus is actually the diameter of the circle, of the given circle. Pretty interesting question, and I hope you have understood what I'm trying to say. So what you will write in the exam, you will mention that the locus of points inside is the diameter or part of the diameter inside the circle, that is perpendicular bisector of the chord joining the two fixed points. Yeah, there is another interesting thing. Let me clear and then you will understand. Let me clear all this. So we have understood that this would be the diameter of the circle. But there is another interesting thing that is mentioned. The interesting thing is that if I join these two points, then this line would also be the perpendicular bisector of the chord PQ. The locus is the diameter of the circle as well as it is the perpendicular bisector of the chord PQ, the line joining PQ. And if you have, you know, uh, we did similar question when we were doing question like question number 4 as well as question number 5. So they were similar questions. So pretty interesting question. I hope you also liked it and you learned something from it. And let's move to the next question. Again, an interesting question, question number 7. Let's start.